Hi, this question is about refraction of a sound wave when it travels from hot air and it goes into another medium which have a different density and different temperature, that is cold air. Okay. Now we are given the path of the sound when it refracts from hot air to cold air, and we are being asked about the frequency and the wavelength. So I will show you the different diagrams. The ray diagram is already shown us in a question, but I will show you how the wave changes. Okay. And also give an example. Will you give an example that what happens when the sound enters in a water or the glass? So let's start. So this is a path of the sound when it go from the hot air to the cold air. Now, is this sound bending towards normal or away from normal? And what is the meaning of that? That what happens when sound bends away or towards? So for this, I need to show you the normal line, the vertical line to the point where the sound is incident. And for this purpose, I am going to show you this dotted line, which is made at a 90 degrees. And what we see that this sound is clearly bending towards normal. Okay. Now this is the angle of incidence and this is the angle of refraction. So angle of refraction is less than angle of incidence. Now, what does it mean when the sound bends towards normal or away from the normal? So let's take a practical example. When sound travels through air, the speed of the sound in air is 340 to 350 meter per second, although it depends on the temperature. But when the same sound, same longitudinal wave enters into the glass, its speed is more than 5,000 meter per second. So it means that the sound speed increases. So this is a diagram of a sound when it go from the air to the glass. So as soon as it incident at that point, it refracts away from the normal and notice a difference. Different its wavelength. So first of all, this is the ray of the sound, means the line diagram. So do you notice that the wavelength of the sound has been increased? So it means that the wavelength always increases whenever the speed increases. So it means that the speed and the wavelength are directly proportional. So if the speed and the wavelength are directly proportional, it means that their ratio, which is equals to frequency, it never changes during the refraction because the ratio remains constant. So this thing, if you apply this concept to this diagram, so just imagine if now this is a sound which is going to the other medium and right now it is hit at that point. So we are given the path of this sound. So at this point we must draw the compressed sound waves. Why? Because its speed has decreased. So do you notice the wavelength has decreased? So it means that the wavelength decreases. And why wavelength decreases? Because it bends towards normal. And why wavelength increases in that example, in the practical example, because it bends away from the normal. So I told you this and I have written as well that sound bend towards normal, that's why the speed decreases and the wavelength decreases. So but what about the frequency will remain unchanged. So the right answer must be option B, frequency is unchanged and the wavelength decreases. Hi, this video is about the variable resistance and we will find out the resistance of this variable resistor, and we are given the IV graph, the current voltage graph across this resistor. Now, this circuit is not given in the original circuit, in a original question, but I have shown you this diagram so that you can understand how did we collect the data. So we always connect an ammeter in series and we always connect a voltmeter in parallel to that circuit component across which you want to get the voltage or potential difference. So this is our variable resistance, which we want to find out. And why it is variable? Because the current and voltage graph is not showing us a linear or proportional line, and it shows us that the current is decreasing. The rate of this current with respect to voltage is decreasing. Okay. So means that the slope or the gradient of this graph is decreasing. Anyways, this is a fixed resistor which in which we are not interested, and I'm sure you know that this is a cell, not an ideal cell. That's why it have a internal resistance as well. Anyways, so when the current flows, the voltage will change across this variable resistor. So what we need to calculate is the resistance at a certain value, right? Since the resistor, according to the Ohm's law, is V over I, okay? So if you are given an absolute value, which is 6 volts, so we will just notice that what is the value of current at that point, okay? At the 6 volt. And we can easily find out that if we notice a corresponding value of current, so it is 9 milliampere, right? So it is half of that. So it is 9 milliampere. So so the resistance should be equals to 6.0 volts divided by 0.009 ampere, and this is volt. So the resistance answer should be in ohms, but here please make it sure that you should represent your answer in correct significant figures. Now this have the two significant figures, right? And this have just one significant figure. So we will round off and we will write our answer uh, in two significant figures. So what calculator gives me 666.6 up to so on, which I can write like this. But if you take care of the significant figures, so if I round it off up to the two significant figures, then it must be equals to 670 ohms. So this 6 and 7 are certainly the significant figures. That's why the right answer is option C, 670 ohms. Hi, this question is about a motion of a charged particle in a uniform electric field. But first of all, how a uniform electric field is produced and how does it looks like? So you can see in a fundamental concept that if you maintain the constant potential difference between them, so just like in our question, it is mentioned that 2.5 megavolts, 2.5 million volts is maintained constant potential difference between the plates, then you can produce this uniform electric field. What does that mean? It means that if you take any point in this vicinity, in this space, at that point electric field will remain constant and that will be uniform throughout. At that point also the electric field will be same. And if you want to find out its electric potential, electric field strength, so you can simply divide the potential difference and the distance between the plates. Now coming back to the question, let's say if this is an electron that is just released from that point, obviously it will be accelerated because of the opposite charge plate, so it will accelerate towards the higher potential. So when it will accelerate, what kinetic energy will it gain in order to cover this distance from the negative plate to the positive plate? Or even if it's not mentioned from negative to positive, we are just given the potential difference, okay? That is delta V, right? It doesn't mean that it's going from negative to positive. It can go anywhere from this point to this point, but between those 2 points the potential difference is given to us. So dear students, now in order to calculate the change in kinetic energy or the gain in kinetic energy, we need to calculate the work done, and that work done according to the work energy principle, it is equals to uh, change in kinetic energy, right? So either this charged particle will gain kinetic energy or lose kinetic energy. Equal amount of work will be done. Now, what is that amount of work done? I just want to quickly show you what is a relation between the work done and the other quantities. Now, we will start quickly from the general the formula of the work done, that says that the electric force times the displacement covered, and I assume that the angle is, now the angle is even 180. But in this case, the electric force and the displacement are in the same direction, so angle is zero. So electric force is EQ, and I'm writing E because E is constant. Q is a charge on electron, and S is the distance between the plates. Because in my specific this example, I'm assuming that it's going from a negative to positive. As I mentioned you, it is not necessary. So it is EQD. Now this E and D is equals to the potential difference. So it means that the work done in that region is always equals to the potential difference into the charge. So we are going to use exactly this thing here. So it is 2.5 multiplied by 10 to the power 6 times 1.6 times 10 to the power negative 19 is equals to the change in kinetic energy, and that will be, so it is 4 multiplied by 10 to the power negative 13 joules. Okay, and that can be written as in a scientific notation. Okay, it's already in that. So if you take the point, bring the point before 4, you can write it like this: negative 12 joules, and 10 to the power negative 12 is called pico, right? So we can say zero point 0.4 picojoule. So you have seen, and this is, by the way, the option C. So option C is the right answer. And you, now this zero point 0.4 picojoules means that whenever the electron will traverse the distance in which the potential difference is 2.5 million volts, this much energy will be the change in kinetic energy. Now this doesn't mean that it will gain kinetic energy or it will lose kinetic energy. It totally depends on the direction of that electron. If it is accelerating towards the higher potential, then it will be the gain of kinetic energy. Then otherwise, it will be the loss of kinetic energy. Hi, this IB Physics past paper MCQ is about the real cell, which is delivering energy to the external resistor as well as automatically internal resistance of the cell. So what we see here that this cell delivers 4 ampere current for the 500 seconds. By the way, when it delivers 4 ampere for the 500 seconds, so you can automatically find out that what total amount of charge that it has delivered, and that must be equals to 2000 coulomb of the charge that it has delivered in that time span. So the internal and external energy dissipations are 1500 joules and 2500 joules. So what you are supposed to find out is the cell's EMF. So we will try to find out by the two methods. This is the method 1. This is a cell and this is its EMF and internal resistance, and this is the external resistance. In a practical circuit, what you see, this is a cell, and internal resistance is actually the opposition offered by the chemical composition inside a cell, which is a chemical inside a cell, and this is your external resistor whom you are delivering energy, and this is the switch. So if you want to calculate the current, you can attach an ammeter in series, and if you want to find out the potential difference across the resistor, you have to attach the voltmeter in parallel. So, anyways, this is our circuit that you see over here. And how can you find out the cell's EMF? We should first of all know what is the EMF means. So the EMF is actually the work done per unit charge. EMF is the potential difference, the actually the potential difference of a cell. So we should say it is the work done per unit charge. But remember one thing, that this work done is actually the energy delivered. It is equivalent to energy delivered by the cell or a battery to move the charge across the circuit if the circuit is complete. So we can also say that the EMF E is equals to actually the energy delivered, which comes from the work done that a cell or a battery do per unit charge. So we should write it. So we have already calculated what is the total amount of charge that is flowing. And what is the total energy delivered is actually the total energy dissipated in the two at the two places. The one is the internal resistance, another one is the external resistance, and we already know their values. So that is 1500 plus 2500 divided by 2000 coulomb, right? So that is equals to 4000 divided by 2000, and it is equal to 2 volts. So this is a EMF of a cell, of this cell. And so option D is the right answer, which says it is 2 volt. Now let's talk about the method 2, which is, so let's start from the law of conservation of energy. You know that the cell is a main component that is delivering energy to the circuit. And the resistor, external and internal resistors, are the one which are dissipating and consuming energy. So if you follow the law of conservation of energy, after the few steps, you will see that the EMF of a circuit can be written as the potential difference across the external resistance plus the potential difference across the internal resistance. And I'm sure you are already, you know, this equation. So now what we will do in this method, we will try to find out the potential difference across the internal resistance, which is I small r, and the potential difference across the external resistance, which is I big R. By the way, for your information, this I big R is also called terminal potential difference if there's just one single resistor in a circuit, external resistor. Now, so what is the I small r? So I small r is the potential difference across internal, which we can calculate by the energy dissipated inside this, and which you know that is the uh, okay, this is 1500 joules divided by how much charge is flowing. That is 2000 coulomb, right? So that should be 15 over 20 is 3 over 4 volts, right? Now, what is the I big R? Is a potential difference across the external resistor, which we can find out by the same way, which is 2500 over 2000, and that will become 5 over 4. So finally, it is, you see that 2 volt is, once again, we get the same answer, and option D is the right answer. Hello, this question is about the motion of a charge in a magnetic field. So let's start with the electron that is moving with a speed v perpendicular. It's very important to note that it is moving at a 90 degrees normal to the magnetic field, having a magnetic field strength B. So you see that this magnetic field strength is applied into the plane, which I have specifically shown you in this section of fundamental concepts, that this field is going from north to the south, and this is external magnetic field going into the plane, or you can consider going into the negative z direction. If you take this is a x-axis, this is a y, and this is a z-axis. So this is the direction of the magnetic field strength, and that is in a negative z direction that we always show with the help of this cross. So when electron will enter into this field, and right now you see this is an electronic gun that is emitting electron in a unidirectional way. So the electron is entering in a straight direction here. So the moment when electron will enter at that point, this is an electron, it will bend and it will move in a circular path, and it will experience a force F given into the question. So our question is, what if you throw an alpha particle with the twice the speed of electron in the magnetic field which have a twice the strength, but you throw the alpha particle parallel, then what will be the force? So dear students, I explain you the alpha particle later. First I will show you what will happen to the electron. So this is the direction of the electron's velocity. Let's say it is moving with the velocity v. And right now I will apply the Fleming right hand rule for the charges moving in a magnetic field. So this thumb shows velocity, this shows magnetic field strength, and this shows the force. So if I apply in this circumstances, so this is the velocity going to the right. Okay, it's my right. Okay, it is into the plane, and this is a force exerted upward. But this Fleming right hand rule is by default applied only for the positive charges. So for electron, I will consider the force exerted downward. So for this reason, and this is exactly the force that is given in the question F. Due to this force, this electron will move in the curved path, and because this force is acting as a centripetal force. So this is a magnetic force. And right now it is exerted towards the center. So I will consider this is exerting, it is behaving as a centripetal force because it is always, it tries to bend the particle. So this force is equals to qvp sine theta. Since the electron entered at a 90 degrees, that's why it is maximum force applied on it. Now the point is, when alpha particle will be thrown, what will happen? So you can see that we are throwing the alpha particle into the region which have a stronger field, and the alpha particle is thrown parallel to the magnetic field with a speed 2v. So basically magnetic field will not be able to bend the alpha particle. It will not be able to accelerate it. Okay, because the reason is it is going parallel. So F is equals to qvb sine theta according to this equation. So the new force is the alpha particle have a 2 times of positive charge, 2e. Its speed is 2v. Its magnetic field where it is thrown is 2b. But the problem is the angle is 0 degrees. So there will be a no force exerted on alpha particle, and hence there will be no acceleration in alpha particle. So the right answer for this question is option A, which says that there is a no force on the alpha particle. If the two coins are placed on a horizontal disk which is moving at a constant angular velocity, so which coin has a more tendency or probability to move out of or to move from that horizontal disk? You will get idea by looking the solution of this question. So what we are looking in this question is there are the two points. There are the 2 points, the point y and the point x. So this is point y and point x taken on that horizontal disk, which is moving with a constant angular velocity. So means it is not changing. It is covering same number of rotations in every unit time, in every 1 second, what we can say. So the point y is at a distance L from the central axis. So this distance is L from the central axis, whereas the point X is at a distance 2L placed from the central axis. And if I show you it's the front sorry, the side diagram. So this is the point Y which is at a distance L, and this is a point X which is at distance 2L from that. So the question is, if the point Y or any object which is placed at a point Y has a speed tangential velocity v, then what will be the velocity of the point x? And what will be the centripetal acceleration of the x if the centripetal acceleration of the y is a? Now you know that the centripetal acceleration is always directed towards center. So I mean to say this is, let's say a is the centripetal acceleration. So if you are thinking that why I am showing you this direction of velocity for the y, so the reason is because when the disk is rotating in anti-clockwise direction, so this point is completing its, just imagine this circle, right? So this velocity v is the tangential velocity. Okay. So what is a velocity at of x, point x, which is placed at a twice a distance as comparable to the y? We can obviously apply this equation. V is equals to r omega. Why? Because this is a linear velocity and angular velocity. They are linked with each other by this equation. So for the for the y, we can say v can be written as equals to L omega, and omega is the constant. So what is for the y? For the x, it should be equals to 2L into omega. So that should be equals to 2 into L omega, and that we can write 2 times V. So it means that the any object if you place at a point X will have a more probability to move out of the disk, because it is moving, its tangential velocity is 2 times more. So it means for X now I should show you this 2v like this. Okay, because its circle is a bigger circle and it have a more velocity. But once again, centripetal acceleration is towards the center. But what will be that acceleration? I want to give you first of all a fundamental concept about this. We know that the centripetal acceleration is equals to v squared over r, but there's another formula that says r omega squared. But why, how can we use these one of them? Because look, for this specific situation, we know that the angular velocity is not changing. So we can write here r omega over r, and right after this, you can prove that it is equals to r omega squared. So we will choose this equation because angular velocity is uniform. So it means that, so if for y we say A is the r omega square, which we can write also L omega square. So it means that for the x, it can be written as 2L omega square, because omega is the constant angular velocity. So that should be equals to, once again, it is very easy to guess that it is 2A. So which means that it should be 2V and that should be 2A. So option B is the right answer, which says 2V and 2A. Hi, this question is about horizontal circular motion. So a fixed mass of mass m is tied with a string of length L. So it is moved in a horizontal circular path. So its speed is increased when it is increased to a certain value v. So let's say this is its velocity v. So at that speed, the tension which is providing the necessary centripetal force to this mass to move in the circular path, that tension becomes so high that the string breaks at the speed v. Now we are given in this question the different combinations, like you see the 4L and the 2V at this speed and this length, and the rest of the combinations we have to test that at what combination the string will break, right? So we are provided the initially the length L and the speed V where the string breaks. So let's start. So, how much force was actually at that moment? So, we can find out, by the way, you can right now see that there is just one force that is providing the centripetal force. In fact, there are two forces which are exerted on it. Okay. So, the one force is the mg, is the weight, which is not towards the center. And the second one is the force of tension. Let's say this is the T max. Okay. Because this is a maximum tension. So if we try to write its equation, so it will be T max is equals to mv square over L. Okay, because here the radius is equals to length. So if any of the combination is equals to mv square over L, then at that combination the string will break. So for the first combination, the T prime, that is a new force. Okay, so the mass is not changed m, and v square is 2v whole square divided by the radius is 4L. So let's see, it is 4v square divided by 4L, and obviously you can see that it has become equals to T max. It means that this is a combination of the length and the speed at which the string breaks. So string breaks, but I will quickly show you the other. So this is equals to mv square over 2L, which is, by the way, dear students, T max over 2. So it's a half of the maximum tension. So that should not be the right answer. A is the only right answer. So it will become mv square over 4 divided by 2L. So in short, this will become maximum tension divided by 8. So it is 1/8 Obviously, it is also not the right answer. So last but not least, you can see it will become mv square over 16L, which is 1/16th of T max. So finally, the option A is the only right answer. Hi, this question is about the radioactive decay of phosphorus into silicon when a nucleus of phosphorus transforms into the nucleus of silicon. It's also called electron capture. So, anyways, what happens? We have to identify what are these two particles, X and Y, which are emitted right at that moment when phosphorus decayed to silicon. Now, what we have to see that what is happening during this reaction. So this 15 turns into 14 means that a number of proton decreases by 1. So if the proton is decreases by 1, what does it mean? It means that actually inside a nucleus of phosphorus, radioactive phosphorus, let's say this was a proton which actually turned into the positron and neutron. And this is actually a positron, or we can also say a beta positive particle. Okay, now this is not a proton, this is beta positive. It is also called positron, and a positron is a particle which has an equivalent mass of electron, and it has a relatively charged opposite of electron, but it is very very less massive than a proton. So what happened exactly? Let's say this is a proton that converts into another a neutron. Let's say this proton converts into this neutron. So I'm going to write a reaction of this. So reaction of this is, so a one proton converts into a neutron, so N10 plus a beta positive particle. Now this beta positive particle is actually a positron, as I mentioned. So it has a plus one relative charge, and zero is just like we play zero for an electron or a beta negative. And the this thing, remember that this is a neutrino. So neutrino is also a particle which is emitted, and some energy is emitted as well. So neutrino, we should select a neutrino. X is neutrino and the positron. That's why the right answer is option D, which talks about this radioactive decay. Hi, if you are measuring the quantity of the macroscopic objects whose mass is relatively larger, then we know that we use the base quantity called mass, and its unit is kilograms. But let's say if you are measuring the quantities at the atomic level, at a microscopic level, then we don't opt the kilograms. Just for our convenience, we adopt another unit, that is atomic mass unit. So AMU. So, what is a standard definition of AMU? Or so in this question, we are dealing that thing actually. So, in this diagram, you see, in a one side of the balance we have a carbon, and on the other side we have a argon. So, argon is almost 3.3 times heavier. So, which is basically 39.9 U. So, U is an atomic mass unit, which we also write like this. So, for all elements in a periodic table, we compare their mass in comparison to the carbon neutral atom. So, if I will place magnesium in the place of argon, then the magnesium is 2 times more heavier than carbon. So, carbon have a 12U and magnesium has a 24U. So we compare the mass of every neutral atom of periodic table in comparison of the carbon. So that's why the option A must be correct, that atomic mass unit is 1/12 of the mass of neutral carbon atom. Hi, this IB Physics past paper MCQ is about nuclear fission reaction. You know that it is a process in which the one heavy unstable nuclide, when it absorbs a neutron, it splits into the two lighter nuclide. which are relatively more stable, but I will give you the explanation of this. And in fact, this question is addressing about the binding energy per nucleon and the binding energy of these fragments and that unstable nuclide. So I will explain you not only theoretically but also from the graph. So let us see. So according to this question, this is that neutron when it hits the nuclide X, it splits into the relatively smaller in size, these two nuclides, whereas the two neutrons are emitted. Now, in the question, in a real question, it is just symbolically like these letters are assigned, but in reality, we have a one prominent example of nuclear fission reaction of uranium. I want to mention you that reaction, and that is when a neutron collides with a uranium 92 235, it splits into the two fragments, which the one is xenon, that is 144 and 54, and the other one is a strontium, that is 38 and 90, plus the two neutrons are released, just like you see in this reaction. And don't forget to write the energy is also released during this reaction. So energy is released. Now, in our question, we have to examine, we have to see that binding energy per nucleon of Y, okay, which is the resultant, right? Divided by the binding energy per nucleon of X, which is a parent element. So we have to find, is it greater than one or the less than one. And second point is, we have to see if we add the binding energies of Y plus the binding energy of the Z, and we divide it with the binding energy of X, is this greater than one or less than one? Let us see. Now, first of all, I will explain you that why the Y and Z are relatively more stable. The reason is that the reason is they are smaller in size. So if they are smaller in size, then what does it mean? It means that within those nuclides of Y and Z, the strong nuclear force, the force which is responsible to bind the protons and neutrons that overcome the repulsion between the same charges, same protons, this strong nuclear force comparably more dominant, more powerful than in the X. So that's why we should say that the Y and Z are more stable. Okay, and I will show you exactly this thing then X. I will show you exactly this thing from the binding energy per nucleon graph, which is very important because binding energy per nucleon is a factor, a decisive factor, which determines the stability of nuclide. It is not a binding energy, it's binding energy per nucleon. So if we see that this, I'm going to draw this roughly, this graph is something like this, right? So in this binding energy per nucleon graph, the top element that is a most stable is always an iron, right? But we are right now talking about the general. So let's say this is a X, okay, because you know that it has a largest nucleon number because it is converting into the Y and Z, it is producing. So if this is a X, then the Y and Z must have a less nucleon number. So dear students, you can assume, like for example, this is Y and this is Z, okay, like they should be close to each other, so obviously they will have the less nucleon number, right? So on this basis, don't you think that the binding energy of the Y is obviously per nucleon, I'm saying per nucleon for Y is obviously more than the binding energy per nucleon for X? What we see here is exactly that thing. So if the binding energy of the Y is more, then it means that it should be 1 greater than 1 because it is more. Now let's come to the second part. We know that the energy is released, and that is the energy which is released. So how that energy is released? That energy is always released whenever this nuclear fission reaction takes place. Certain amount of mass of the X will be lost, and that will convert into the equivalent amount of energy which is released during the reaction. It means that the mass of X is more than the combined mass of Y and Z. So remember here, I'm talking about the nuclear mass of X is more than the sum of nuclear mass of Y and Z, because the difference of that mass is converted into the energy. So which means that the binding energy of X, because it's a heavy element, it's more than the sum of the binding energy of Y plus the binding energy of Z. It means that if we take the ratio, so that ratio should be more than 1. My mistake, less than 1, obviously, because it is more. So option C is the right answer for this MCQ. Hi, whenever we try to find out the energy released during a nuclear reaction, or you are trying to find out the binding energy of nucleus, or energy that is released during a nuclear radioactive decay. So, from what is the source of that energy? So, Einstein's equation explains it very well. It tells us that some particles converts their mass converts into the equivalent form of energy, equivalent amount of energy. And we can exactly find out because this is quantitative in nature. So, in this question, what we are trying to do is we will find out that what is the energy equivalent to the mass of one proton. Now, we know that the mass of one proton is, I should write it like this, H11 is 1.00776 atomic mass unit. So if we convert this mass into the equivalent amount of energy, so we should use this equation: energy is equals to the mc square, right? This is the indirect process, but you can also convert it directly if you multiply this number with 931.5 mega electron volt, and 1 electron volt is 1.6 times 10 to the power negative 19 joules. So if you follow this method, so you must write here the mass, which is 1.007276 times the 1U is equivalent to 1.6606. 1.6606 times 10 to the power negative 27 kilograms. This is the mass, and this is a speed of light. So 3 times 10 to the power 8, it's square. So your answer will be in joules. You can adopt any one of these two. So if I multiply this number with this number, right? So I get exactly 938.27, or let's say 3 times 10 to the power 6. This is already written here, times 1.6 multiplied by 10 to the power negative 19 joule. Now we can take this point, we can write it into the scientific notation. So that can be written as 9.38 multiplied by 10 to the power 2 times 10 to the power 6. So this 10 to the power 2 and 10 to the power 6 can be written as 10 raised to the power 8. So finally, you can match that we have written our answer in what which match with one of the options. So that should be obviously option D is the right answer. This question is also not a part of our new syllabus because it's about the primary and the secondary energy sources. So it's excluded. Let's say if there are the two distant planets where the life is 100% impossible, and I have to compare while living here on Earth, I have to compare which one of them is hotter by just seeing it. This question is going to address this thing. So let's say these are the two planets, planet X and planet Y. What question says that the planet X is less hotter, and by the way, both are the black body radiators. Black body radiators means their emissivity is 1, and it means that all the energy that these two absorbs, they radiate all of them. This is what it means, black body radiation. So it means that both of these planets are emitting, releasing, radiating all of their energy in the form of radiations, and we are given the intensity and wavelength curve by in these options. So, and according to the question, the planet X is less hotter and the Y is more hotter, means the Y temperature is more. So the Ty is more than Tx. Well, first of all, I will explain you what the intensity and wavelength graph tells us. According to the Stephen Boltzmann law, and according to the modern physics, that all the energy that is radiated from the planet is not radiated in a form of single wavelength. It is radiated in the entire electromagnetic spectrum, and which you can see easily by looking the different wavelengths. And what is special is that this wavelength, which according to this graph has a maximum intensity, I will call it maximum wavelength. Why? Because this is that specific wavelength of light which carries the maximum portion of energy released from the planet. And just last thing, the area under the graph tells us more interesting thing, and it tells us that how much energy overall is radiated from the planet. So if a one planet have a higher temperature, so obviously its area must be larger because it will radiate more energy, and that is actually we know that the power is proportional to the temperature is power 4 according to the Stephen Boltzmann law, or you can also say luminosity is proportional to the T raised power 4. And now, if I connect this intensity wavelength graph with the planet situation, then remember that this planet is going to release the minimum wavelength, means the gamma ray, to the maximum wavelength electromagnetic, which is a radio wave and also visible light. And for this reason, I'm going to show you all of them to you. So this was just possible for me. So I have tried to show you that whole electromagnetic spectrum is radiated from both of the planets. Now, according to the question, they say the planet X is less hotter, and the graph is actually shown by the dotted for X. You see that the dotted means that in all of these options, this dotted curve is actually representing the intensity wavelength curve for the planet X. And what will be for the planet Y? Let's take advantage of Wien's law. So what the Wien's law says that it relates the temperature and the wavelength. Which wavelength? The maximum wavelength, which I mentioned you here. The maximum wavelength doesn't mean it has a maximum length. No, means that it is that light which carries the maximum energy. So it says that the product of the temperature and the maximum wavelength is constant, and that constant is 2.9 times 10 to the power negative 3 meter Kelvin. So that is constant. It means that the maximum wavelength and the temperature is inversely proportional. So like this. So if you use this information, what information? That we know that the temperature for the X is less than temperature for the Y, which means that now logically we can derive the result that the maximum wavelength emitted for the X would be larger than the maximum wavelength for the Y. It means that, so, dear students, let's apply now the results that we have learned. Now, I'm going to compare the two. So, I'm saying, let's say this is the graph for the X, and this is the wavelength for the X, lambda X. Now, what we have learned that the wavelength of X must be larger. So it, and secondly, the temperature of Y is more. That's why the planet Y must release more energy. So it should have a more area under the curve. So which directly leads what, where it does it lead to? Don't you think it leads to exactly something like this curve. Because if you see that, the area under this curve is first of all more than the area under the curve for the x, which means more energy is released. And secondly, dear students, you can compare the wavelength for the y is obviously more less than the wavelength for the x. So it means that this is for the y, and you can easily identify which one should be our right answer. So none other than option D is the only possible right answer for this question. Hi, this question is about albedo. So if the average albedo according to the question is of glacier ice 0.25, by the way, it means that the 25% of any intensity of light that is incident on glacier is reflected. Okay. So if it is reflected, then 75% of that intensity is absorbed. So I will give you the little background of the power and also that if our sun is so hot that its core temperature is 15 million degrees Celsius, its surface temperature is 5500 degrees Celsius, then why does not it burn the earth? Okay, so what actually happens when the intensity of the light of sun that is incident, if it is I, so how much is reflected? So 25% is straight reflected, which means it is 0.25 I. And then how much is absorbed? So let's find out. It should be 0.75. So 0.75 I, okay, or the power P divided by 0.25 of incident power. Remember that I'm saying incident power, right? So this is incident power. It's not the it's a 75% of incident power. So you can easily calculate it. It should be 3. So right answer is option D, but please stay in a video and see what happens. So if 25% is reflected, then what happens with the rest of that? The rest of that is radiated in a majorly in a form of infrared, but all of that will be radiated if we consider it a black body radiation, but it is of course not. So some part of absorbed power is radiated. Now when the sun radiates a lot of energy, so what happens, this energy is coming directly on the surface of earth. So what I'm considering that all of the light that incident on earth is not eventually incident on the surface of earth. Just one fourth of the area of earth absorbs that light. Okay, just one fourth. And and further, that light, a part of that light is reflected, and this is absorbed. So that absorbed power actually rises the temperature of the surface of earth. So I hope you understand. In case of any question, let me know in comments. Bye.